Hello everyone. So the question is, we have the correct statement about probability density, except that at infinite distance from nucleus is, first option is it can be 0 for 3p orbital, second is it can be 0 for 1s orbital, third it can be 0 for 2s orbital, fourth is it can be negative for 2p orbital. So in order to find out the correct answer, we have to first have to create the probability density graph for each of these orbitals. And the probability density graph is drawn between r square r versus the distance between the atom and the nucleus, the basically distance between the electron and the nucleus. So in order to do that, we first have to calculate the radial node, and the formula of the radial node is n minus l minus 1, where L is the azimuthal quantum number. So to calculate the radial node of, let's say, 1s, so the n is stands for this 1, the coefficient of the orbital, so we'll write 1, and L is the azimuthal quantum number for s, which is 0 and minus 1. So for 1s it will be comes as 0, 1 minus 1, 1 minus 0 minus 1. And if we want to calculate for 2s, it will come as, for 2s radial node is 2 minus 0 minus 1. So the radial node of 2s will be 1. And to calculate the radial node of 2p, the radial node for 2p will be 2 minus the azimuthal quantum number for the p is 1. So 2 minus 1 minus 1, which is 0. And similarly for 3p, it will come as 3 minus 1 minus 1, which is 1. Now we will calculate the graph between 1s, 2s, 2p and 3p. So let me move this. So the graph for 1s orbital, the probability density graph for 1s orbital is like this. Here it is, R and R. So as you can see, it is not touched to 0. So this option is already false. As you can see from the graph, it is not 0 for the 1s orbital. Now we will draw for the 2s orbital. So for 2s orbital, the graph is this. Something like this. So as you can see, for 2s orbital, it is also almost 0, and we have calculated the radial node also, for it was also 0. So this option is also false. Now for the graph for the 2p orbital is something like this. So for 2b orbital, it can be never be, it is shown it can be negative for 2p orbital, and which is wrong, it can never be negative. The wave function for the orbital can never be negative. So this option is also false. Now the graph for the 3b orbital. So the graph for 3b orbital is like this. So for 3b orbital, the wave function can be 0. So this is the only option here which is true. So the correct answer is, it can be 0 for 3b orbital.